Okay, let's get started. I just want to sleep, but it's okay. I will make this at least if the students need it. Let's take a look at this Chapter 8 study guide. If you look at the first two questions, these are really just basic proportionality ratios. The whole point of these questions is so that you're going to be ready to tackle the later questions in 8.4 where you're going to have to make ratios, but yeah, should be pretty simple here. By the time you're watching this, you'll have had enough practice. Basically, these two are going to end up on the same side, right? You're just cross multiplying them. So let's do that. That's 8 times 6. And then these two are going to end up on the other side. When you have those, make sure to put the parentheses, right? So you're going to get 3 times x minus 6. A couple things you could do here. I'm just going to multiply these out. That's going to give you 48. If you distribute these across, you're going to end up with 3x minus 3 times 6 is 18. Okay, pretty simple. These are going to cancel out. This should give you 66 is equal to 3x. And then divide by 3, divide by 3. You should end up with 22 as your x value. Nothing too crazy. Alternatively, you could have seen something else. Like let me write this out here. If you have 8 times 6 is equal to 3 times x minus 6, you can divide both sides by 3. And then 6 divided by 3 is just going to be 2. So you're just going to get 8 times 2 is equal to x minus 6. That's going to give you 16 is equal to x minus 6. And then if you do plus 6 on both sides, you'll get the same answer. So kind of an interesting thing there. Number 2, multiply these across. Again, that's going to give you 2 times 7, right, is equal to 9 times b minus 6. So again, these two multiplied together, and then these two multiplied together. Cross multiplying should be pretty simple by now. This is going to give you 14 is equal to, let's distribute. You're going to end up with 9b minus 9 times 6 is 54, or negative in this case. Add 54 to both sides. That's going to give you 68 is equal to 9b. Kind of a strange one. I know we haven't dealt with much decimals, but this one actually does end up giving you a weird little decimal. It's about 7.555 dot dot dot, which is approximately about 7.56 when you round it. So again, a decimal answer in that case, but that's okay. Sometimes you'll get decimals. And this fraction, you can't really simplify it, so keep it in that form. Circle either of these, okay? State if the polygons are similar. Okay, so these are going to be just a matter of checking each individual ratio. So for example, let's look at 4 and then 20, those two right there. So 4 and then 20. I mean, if we want to highlight them, you can. So let's do the next two. What about 3 and then 15? And then let's color code this one, the bottom sides, 6 and 30. You're just forming a ratio between all of them. And then technically you have the fourth side, but you know that's just going to be the same thing. So you don't really need to write it again, but in case you want to, let's write that out. So here's the idea. Do these simplify down to the same decimal number or fraction? Well, let's take a look. This one, if you think about it, that's just going to be 1 over 5, right? I mean, let's check this one. If you divide by 3 on the top and bottom, common factors, 1 over 5 once again. Oh, what do you know? Well, you're going to get 1 over 5 once again. And we already know this is 1 over 5. So Yeah, pretty simple. These all check out. They're all the same number. These are all 0.2 on a calculator. And so this is how you know the ratios are similar. We can just say that they're similar. That's your answer. If you look at this next one, quick note, if you notice that the angles are in the same position, in this case, they're both in the bottom right, left-hand corner, and they're the same exact number, well, you still need to check the ratios of each individual sides. But let's say this was 61 degrees or something, right? This is 61 and this is 60. Well, then automatically this would have been not similar, okay? But in this case, we do have to check it because they are the same, and so we don't know what to conclude yet. So let's pick the ratios. This is going to give you 6/18 for the first one. What if we did 4 and 12? Again, you could use a calculator if you get stuck. Okay, well, in this case, let's see if it simplifies to a fraction. It does, 1/3. What about this one? 1/3 as well. And then you might be wondering, how come we didn't check these two? How come we didn't check these two? Well, there's no need because the sides are exactly the same. You notice that 6 and 6, 4 and 4. I mean, yeah. So in this case, these two check out, okay? In the case that you can't really simplify the fractions, use a calculator. But in this case, you know that they are similar. All the ratios are the same, including the other two that we didn't check. Technically, the other two would also be 1/3, 1/3, right? Okay, number 5 and number 6. Okay, a couple things here. You might be wondering, okay, this is kind of like the number thing being different that we talked about, but don't be fooled. These are in different positions, right? Different positions. If you really think about it, if this is 140, that means that this must be 40 degrees because they need to add up to 180, right? Add up to 180. Same thing here. This needs to be 140 on the top so that they need to add up to 180. So really the angles are the same. It's just that they were in different positions. Okay, so we can't prove anything. This doesn't mean that it's automatically similar. We have to check ratios. So let's do that. Let's check the top. And you'll notice that the bottom ones, again, are the same. So we only need to check it once. 12/6. And then let's try the other two. That one, which turns out, actually, should have looked at this. This is all 12/6. So, I mean, 12/6 is just 2. 12/6 is just 2. In fact, all of them are going to be 2. So this is similar. Let's look at this last one, number 6. Again, these angles are actually the same, right? Because they need to add up to 180. So if you actually calculate 180 minus the number, 180 minus 75, you'll get 105, and then the other way around, you get 75. So we can't really conclude anything. We have to check the ratios once again. Let's see if it's similar this time. So 20/25. Okay. Let's try 24/45. Okay, well, let's take a look here. In this case, if you look at what the fraction becomes, this becomes 4/5, right? But here's the thing about this guy. You might not know what it divides by, but just try numbers out until you maybe get a common factor. That's going to be just 8/15. And the other ones we don't need to check just because it's going to be the same, right? Yeah, like you might as well take this and just duplicate it. It's going to be the same thing. And so, unfortunately, you'll notice that this and this, these are the most simplified forms, but these are not the same number, okay? This is about 0.8, and then 8/15. 8 over 15, according to my calculator, is going to be about 0.53. It's going to just keep going. So these are not the same number, unfortunately. They do not equal each other. So this is not similar. Okay. Let's keep going. The polygons in each pair are similar. Find the missing side length. Okay. So they're already assumed to be similar. So there's not much that you really have to do here other than the fact that you take the ratios of each other. So let's do that. You get 10 over 5. Okay. If we start from the left shape, then end on the right shape. Okay. And then you're going to do the same thing for the other one. This and this. Remember, we don't really like using question marks. We're just going to call that x for a variable. And then we're going to do 12 over x. Okay, we could cross multiply here. So if we cross multiply, you're going to end up with 10x is equal to 12 times 5. Well, that's just 10x is equal to 60. Well, 10x equals 60, just divide by 10. You're going to end up with x equals 6. And that'll be your answer. Okay. Once you plug it back in, right, you should be able to see that, oh, these are similar shapes because all you have to do is multiply both of them by a constant of 2, and then you'll end up with 12, and you'll end up with 10. Let's try this one. So again, our goal is to find x, and we know that they're similar, so we know that we can use them as similar proportions. So I'm just going to take a look at this guy and this guy. Doesn't matter how you form the ratio, but I'm just going to do 15 over x. And then in this case, they've given us two different sides to work with. We could use either those two, or we could either use these two. It really doesn't matter. In this case, just because they gave us both infos. If they hadn't given this to us, then you would have to use these two, right? But in this case, we do have these two bits of information, so we're good. Okay, ask yourself, should it be 21 over 14, or should it be 14 over 21? Well, because we started from 15, the left side, we also need to start with 21. So 21 goes there, 21, and then divide that by 14. From here, again, just cross multiply. I fear that this is a little bit messy. So that's going to give you 15 times 14 is equal to 21x. 15 times 14 is 210, which is equal to 21x. Divide this by 21, divide this by 21. Well, you get this nice little number, 10 is equal to x. That's page 1. Let's keep going. It's the same idea on this page, except you're taking it a little bit more complex equations. So let's do 4 and 12. So 4 and then 12. And then let's do these two. You might be wondering, what do we do with this guy? Well, there's nothing to compare it to on the other one, so we're just going to ignore that guy. He's not very helpful to us. But we do have the bottom ones to compare, so that's what we're choosing. So in this case, let's do 1 plus x divided by 24. We have to follow that order because we went top to bottom, as in the top shape to the bottom shape. And so from here, a couple things you could do. You could cross multiply right away, but if you're smart like me, just kidding, I'm okay. You could notice that this simplifies, right? This is technically just 1 over 3. So 1 over 3. This will save you a little bit of pain. You won't have to calculate big numbers as much. Let's cross multiply. So this guy goes here. Oh, geez, that looks kind of messy. So I'm going to change back to this. So that goes there, and that goes there. So that's just going to be 1 times 24. 1 times 24 is just 24, so that's 24. And then we know that 3 times 1 plus x, that's going to become 3 times 1 plus x with parentheses. Distribute, distribute. You're going to end up with 24 is equal to 3x, 3 plus 3x. Subtract 3 on both sides. You're going to end up with 21 is equal to 3x. Almost done. So divide by 3, divide by 3. You're going to end up with 7 is equal to x as your answer. Okay, they gave us a couple of bits of information here. So x plus 8 and 5. Okay, so x plus 8 and then 5. What else? Okay, they gave us 2 things. So this and this could work, or you could do this and this. It doesn't matter. You can solve it however you like. It'll actually, since they're the same distance, it's going to be the same answer. This is going to give you 12 over 4. Going to pull a pro gamer move here. Instead of just cross multiplying, I'm just going to simplify it to x plus 8 over 5 stays the same, but we know that 12 over 4 is just 3. So let's just put 3 here. Move this guy to that side by cross multiplying. So if we cross multiply, that's going to give you x plus 8 equals 3 times 5, which is just x plus 8 is equal to 15. Subtracting 8 will coincidentally give you the same answer as a previous problem. You get x equals 7. Yay! Okay. And again, you could have cross multiplied. Totally up to you. That just gives you a lot bigger, I don't know, just a lot bigger of numbers. I don't want to deal with that. State if the triangles in each pair are similar. If so, state how you know they are similar. Okay, so let's take a look here. First, right off the bat, you should identify, is it going to be AA? Is it going to be SSS? Or is it going to be SAS? Or is it none of them? That's the idea. And so in this case, notice you have a side and you have a side. And in fact, in between them, you have an angle. Same thing for this one. So this is either going to be SAS if it works out, or if it doesn't work out, then it's going to be not similar. But we don't know yet. So let's start this. So a couple ways you could form the ratio. Some people don't realize that they could form a ratio between the smaller side and then on the same triangle. So you could do 99 over 121, and then you could do smaller side over the greater side. And you can see whether or not do these equal each other. I'm just going to do it the way that we taught it in class. But again, either way you could do it. So smaller side is 99 on this one, and the smaller side is 45 on this side. Okay. So I'm going to do, for the short side ratio, I'm going to do 99 over 45. And then for the long side ratio, that's going to be 121 over 55. We have to follow the same order. We started from this side, so let's go to this side. Well, I'm not going to ask you guys to solve this out. This is actually just going to be 2.2 on a calculator. Just plug it in. 2.2 on a calculator. And it turns out these are the same as each other, okay? The only thing that we need to know is the angle that's between those two sides congruent? Well, turns out they are. Because the vertical angles, remember when they form this little X shape, vertical angles are congruent. And so you have a side, you have an angle, and you have a side, side, angle, and a side that are similar. Therefore, this is similar. And how do we know that? Well, that's going to be SAS similarity. This is going to be your answer. Let's do the next one. You have 3 different sides. Okay, should be a dead giveaway. You have a side, you have a side, you have a side, right? I didn't even go in the right order, but basically you have 3 sides that are being compared. So it's either going to be SSS, or if it doesn't work out, it's not going to be similar. It's one of those two. We don't know. So we can already eliminate 2 answer choices. I know we didn't do that last example, but it can't be either of these. It's going to be either this one or this one. Let's find out. So again, let's create our short, medium, and then our long ratios. So your short ratio, the shortest side is 9 on the first one. The shortest side is 24 on the bottom one. So our first ratio is going to be 9 over 24. Okay. Our medium one is going to be 12 and 32. So 12 over 32. And then our long one is going to be 18 over 48. Okay, I'm not going to ask you guys to simplify this in fractions. You totally can, and I think it's pretty easy enough if you're good enough at fractions, but just use a calculator. That's going to be about 0.375. What do you know? This is also 0.375. In fact, all of them are going to be. So check, check. Oh, that's ugly. Hold on. Check, check, check. Because these are all the same ratio, we are going to call this similar by SSS similarity. SSS. Okay. Okay. Let's do the next one. So here, let's take a look. This is actually kind of nice. You have a 66 on the bottom, right? And then you don't have one on the bottom, actually. I mean, 66 on the top, you don't have one on the bottom. And then you have a 23 on the top, but you don't have one on the bottom. These are totally different angles, right? And so automatically, this is just not going to be similar. Not going to be similar. And the reason being is because you need at least 2 angles that are congruent to each other in order for it to be similar. But unfortunately, none of these are going to be. So it's not AA, does not work. We don't have any other bits of information. It's definitely not SAS, definitely not SSS. We don't have any of these bits of information. Let's look at this one. Sometimes people don't realize when they create that little Z shape. This is not a case where you do that. That would only be in the case that the 2 lines are parallel to each other. So be very careful about that. If that's the case, then you can form a Z like this, which means this would be congruent. But again, you can't do that. There's no parallel symbol here. Okay. All you know is that these 2 are congruent because those are 2 tick marks. And then you have, these are vertical angles, so these are congruent. Wait a minute, that's all we need. We have an angle, we have an angle, we have an angle, we have an angle. And so truly, the only answer that we need is that we know they're similar. At least 2 angles are congruent. And by angle, it is similar. So done with the second page. Let's move on to the final page. You have this one right here. We have SRQ is similar to FGH. How do we prove that? Okay, well, again, take a look. This one has how many tick marks? Like 4. This one has like 3. This one has 2. This is 1. They're all different from each other. Pretty quick one, right? None of these are similar. So AA would have been it, but I mean, totally fails here. None of the other ones apply. Okay, so number 16, we are moving on to 8.4. These are kind of crazy numbers. I do apologize, but again, just take a look here. Actually, sorry, this is not 8.4. We are still on triangle congruency. Well, sorry, triangle similarity. Well, if this whole thing is 117, then this section right here, that must be 117 minus 72, right? And it turns out that's 45, which means this little section is that. So 45, right? These two add up to 117. And then again, do the same thing. This is going to be 156 minus 60, which, as it turns out, that is going to be 96. Right? These two add up to 156. So we know that, again, what this triangle really is it's two triangles, one big one and one small one, that are overlapping. And it's told to us that, I mean, the angle that's being shared by both of those triangles is h. So those two angles are actually congruent to itself right here. So we're going to mark that, maybe even highlight it to make it more pronounced. Okay, well, let's try to figure this out. It can either only be side, angle, side by similarity, or if they're not similar, then they're not similar. We have to prove this. Let's create a ratio. So I'm going to take it in this order. 60 divided by 96. Right? I kind of went in this order. That's okay. In that case, we have to go this way for that one as well. So 45 over 72. Well, if you just plug this into a calculator, you're going to get 0.625, 0.625. Check, check. That means these two are going to be, according to the congruent angle that is between those two sides, we know that they are going to be similar. Again, that's because side, angle, side, right? Side, angle, side. It's not angle, it's not like we were given two angles, it's not like we were given side, 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 right? We didn't know what the last side was. And so it's either not similar or it's similar by SAS, and it turns out it was B. On to 8.4, the final boss, as we called it. Again, let's get rid of this guy. We're going to call that guy X. And so this guy and this guy, that's one ratio, X over 21. And then this guy and this guy, well, that's going to be 20 over 12. Okay, you could simplify this. I'm just not going to. Just know that it's an option. I did that in a previous problem, so I'll just show you. You can just cross multiply like normal. So that's going to give you 12x is equal to 20 times 21. Well, 20 times 21 is going to be 420. Once you divide that by 12, you're going to end up with x equals 35. And that's it. Easy as can be. Really, number 18 is kind of similar, right? You're still creating the ratios. So let's do this over that. That's going to be 3 over 4. And then let's do 6. Let's do 6 over that, which is, again, let's just call it x. 6 over x. So cross multiply, you're going to end up with 3x is equal to 4 times 6. Well, that's like saying 24, in which case, if you divide by 3, you get a nice, cool x equals 8 as your answer. Okay. Okay, down to the last two. Again, I'm just going to replace this as x. I'm going to replace number 20 as well with x. Just don't like the question mark that much. So if we color code this, this is x already. But remember, we need to figure out what is this. Well, if the total length from here, from the bottom all the way up to the top is 18, then this section right here must be 18 subtracted by x. It's the total minus the partial length. So 18 minus x, just let that sink in. That's going to be that section right there. If the order was switched, then as we're going to see in the next example, it's always the total that comes first, okay? Because it's being taken away from the total. And then again, kind of like what I mentioned, this is the total, so that would be 12 minus 4, which in this case is going to be 8. Okay. And so let's mark this down, 8 and 4. So that's like saying 18 minus x over x is equal to 8 over 4. I don't know if the color coding helps, but I guess I'll do it for the sake of this problem. And so number 19, again, let's continue going forward. This guy right here, you can notice that 8 over 4 is just 2. So before you cross multiply, again, you could totally do it that way, but instead of doing that, I'm simplifying it first. From here, let's multiply across. That's going to give you 18 minus x is equal to 2x. Add x to both sides. This is going to cancel. You're going to get 18 equals 3x divided by 3 divided by 3. What do you know? You're going to get 6 is equal to x. That's going to be your answer. Last one. Again, remember what I said? If the whole thing is x, right? Well, then if we create a ratio between 12 and this other side, this needs to be a section that is x take away that smaller section right there, which is 12. So it has to be x take away 12. And so x minus 12 is going to be our expression. Again, the total is always first because the total minus the partial is going to be the remaining segment. And so that's our first fraction. Doesn't matter how you write that one. But again, it might help to actually highlight the guys that we're using. I know I didn't do that in the last problem, but and then this guy and this guy. So red and red. Let's create our ratio. It does not matter which one you put on top. If you choose this on top, right? If you do x minus 12 over 12, well then you have to pick this guy on top, 25 over 15, just because these two are going to be the same. Now, I already worked it out in advance. I think I did it the other way, 12 over x minus 12. And so it's going to be this over that. Well, that means it's going to be this over that because it has to be the same triangle. Or it has to be in the same order that you pick the ratio, which is, this is the way that I'm doing it. Okay. Okay, again, you could totally do this. You could totally cross multiply this to that side, cross multiply this to that side. You get one big happy family, but look at how ginormous these numbers are. Look at this. It's a headache. You don't want to do that. I mean, it's fine if you do, but I don't want to do that. Don't make your life harder than it has to be. It's already hard enough. So What I'm going to do is program remove again, this guy right here, divide by 5, divide by 5. You're going to get 3 over 5, right? Simple. Much easier numbers to work with. And then you could cross multiply. So that's 3 over 5. So cross multiply, yikes. Cross multiply, cross multiply. That's going to give you 12 times 5 is equal to 3 times x minus 12. 12 times 5 is 60 is equal to 3 times x minus 12. I'm going to show you another pro gamer move. Think about it. Instead of distributing, which you could totally do that, I'm just going to divide by 3 because then these two cancel. They just go away. Okay? Just watch this. So divide by 3, divide by 3. You can do this method if these two numbers are divisible. You can't always do this. Like imagine this was like 65 or something. Then that's not divisible by 3. And so you can't do this. It wouldn't help you out. But in this case, this is divisible. This gives you 20 is equal to just x minus 12 without the parentheses. Well, as long as you cancel it correctly, you're going to end up with 32 equals x, or x equals 32. Make it nice and gigantic just because it's the last answer. And there you go. Again, you could have distributed this. You could have done 60 equals 3x minus 36, add 36, but it's a lot less pretty in my opinion. You'll get the same answer though. Okay, ding. Okay.